Students, today I will discuss the topic image enhancement, histogram equalization. Now, histogram manipulation basically modifies the histogram of an input image so as to improve the visual quality of the image. In order to understand histogram manipulation, it is necessary that one should know the knowledge about the histogram of the given image. Now, what is histogram? The histogram of an image is a plot of the number of occurrences of gray levels in the image against the gray level values. The histogram provides a convenient summary of the intensities in an image, but it is unable to convey any information regarding spatial relationship between pixels. An image histogram is a graphical representation of the distribution of pixel intensities in an image. It plots the frequency of pixels at each intensity levels ranging from 0 to 255 in the case of 8-bit grayscale images. Key features of an image histogram: in the x-axis, it represents the intensity levels of the pixel typically ranging from 0 to 255 for 8-bit grayscale images. In the y-axis, represent the number of pixels at each intensity levels. Now here is an example. Here pixel intensity taken from the value 1 to 8. Now in the x-axis pixel intensity is plotted and in the y-axis its counts is plotted. Now see the given diagram. Pixel intensity 1. How many pixels? 1 and 2 pixels. So in the graph we are just plotting this. Pixel intensity 2. How many pixels? Only single pixel. Pixel intensity 3. How many pixels? 1, 2, 3 pixels. So in the graph we are just plotting. Pixel intensity 6. How many pixels? 1, 2, 3. Pixel intensity 8. How many pixels? 1, 2, 3. Now next, histogram of a dark image. If you observe the histogram of a dark image, we can see that the histogram of a dark image will be clustered towards the lower gray levels, just lower gray levels. Now, what will be the histogram of light image? The histogram of bright image will be clustered towards the higher gray levels. Histogram of a low contrast image. For a low contrast image, the histogram will not be spread equally, that is, the histogram will be narrow. Now, histogram of high contrast image, if we observe it, for a high contrast image, the histogram will have an equal spread in the gray level. Now see the given diagram. Before histogram equalization, the image quality is very poor, and after the histogram equalization, we can observe that image quality enhanced. Now you can see after histogram equalization what happened. For every gray level value, there are pixels are present in the given image. Now another example, here this is an old image and we have plotted its histogram, and after histogram equalization we can see in the new image, after histogram equalization the histogram is spread uniformly and we can see the image is also enhanced here. Now why use histogram equalization? We can improve the contrast of the given image. It helps improve the contrast, especially in images where the details are hidden in dark or light areas. Visual clarity. It makes details more visible by redistributing pixel intensities. Now, histogram equalization, it is a process that attempts to spread out the gray level in an image so that they are evenly distributed across their range. Histogram equalization reassigns the brightness values of pixels based on the image histogram. Histogram equalization is a technique where the histogram of the resultant image is as flat as possible. Histogram equalization provides more visually pleasing result across a wider range of images. Now, we have to follow this procedure to perform histogram equalization in a given image. First step, compute the histogram of the image. For a grayscale image, calculate the histogram which represents the frequency of occurrence of each intensity level from 0 to 255 for an 8-bit image. The histogram is a plot of intensity levels on the x-axis and their corresponding frequency on the y-axis. Second step, compute the cumulative distribution function. Now the CDF is the cumulative sum of the probabilities of intensity values. For each intensity level I, the CDF is calculated as using this following formula, where Pj is the probability of intensity J. Third step, normalize the CDF. Normalize the CDF by scaling it to the range 0 to 255. Normalize the CDF is to span the full intensity range, that is from pixel intensity value 0 to 255. This is done to stretch the intensity value so they cover the entire range. Fourth step, map the original intensity levels to the new levels. For each pixel in the original image, map its original intensity value I to the new intensity value using the normalized CDF. This step essentially replaces each pixel's original intensity with the new value based on the CDF. Next step, generate the equalized image. Construct a new image by replacing the intensity values of the original image with the corresponding new values from the previous step. Next step, display the result. Show the original and equalized images to observe the contrast enhancement. The histogram of the equalized image will be more spread out, potentially increasing the visibility of details in the given image. Now there is one examples I will discuss now. Suppose that a 3-bit image, here L value equal to 8, 3-bit image of size 64 into 64 pixel has the intensity distribution shown in the following table. Get the histogram equalization transformation function and give the probability of SK for each SK. Now in the x-axis we have to plot the pixel intensity, and in the y-axis we have to plot the number of pixel corresponding to the given gray level value. Now according to question, it is given that for the pixel intensity 0, there are total number of pixel is 790, pixel intensity 1, total number of pixel is 1023, pixel intensity 2, total pixel is 850, and so on. Now I will show you the histogram of the input image. Pixel intensity 1, there is almost 1023 image according to the question. Pixel intensity 1, 1023 pixel. Pixel intensity 0, 790 pixel. Pixel intensity 0, there are total 790 pixels. So we can easily plot the graph. Now how to perform the histogram equalization, now I will tell you this thing. Now according to the question, it is given that pixel intensity 0, there are total number of pixel is 790. Pixel intensity 1, total number of pixel is 1023. Pixel intensity 2, total number of pixel is 850, and so on. So first of all, perform this operation. Find out probability of Rk equal to Nk divided by N. Now this pixel intensity is 0, total number of pixel is given 790. So probability of occurring this pixel intensity 0 is 790 divided by 4096, because according to question it is given that total number of pixel is 4096. So in this way we have to calculate probability distribution function for the pixel intensity 1, 1023 divided by 4096. For pixel intensity 2, probability distribution function 850 divided by 4096, that is equal to 0.21. And similarly for pixel intensity 7, probability distribution function is 81 divided by 4096 equal to 0.02. Next we will calculate the cumulative distribution function. Cumulative distribution function, now initially 0.19, it will be same as it is 0.19, then 0.19 value will be added with 0.25, and cumulative distribution function is 0.44, then 0.44 will be added with 0.21, and the cumulative distribution function is 0.65, then 0.65 will be added with 0.16, and the cumulative distribution function will be 0.81. 0.81 will be added with 0.08, and the cumulative distribution function equal to 0.89. Then 0.89 will be added with 0.06, and the CDF will be 0.95. Then 0.95 will be added with 0.03, and CDF will be 0.98. Then 0.98 will be added with 0.02, and the CDF value equal to 1 now. Next we have to perform this operation CDF into L minus 1. Here L minus 1 is nothing but maximum gray level value here that is 7 for the 8-bit grayscale image. Now CDF, after performing this operation CDF into 7, we have the corresponding value. Here we having 1.33, and equalized output gray level value equal to 1. Here for the pixel intensity 1, output gray level value equal to 3. For the pixel intensity 2, after histogram equalization, the output gray level value is 5. For the pixel intensity 3, after histogram equalization, output gray level value is 6. Similarly, input image intensity 4, after histogram equalization, the output intensity is 6, and so on. For input gray level value 7, the output gray level value is also 7 here. Now we have prepared this table. After performing this, now just count. For the input gray level value 0, there are how many pixels? There are total number of pixels is 0. Because for input gray level 0, there are output gray level is 1. In the output gray level, there are no pixel whose value having the intensity 0 now. So here equalized output gray level 0 value, there are total number of pixel is 0. for the input gray level value 1, output gray level value is 790. Output gray level value is 2. Total number of pixel is 0. Output gray level value 3. Total number of pixel is 1023. Output gray level 4, there are total number of pixel is 0. Output gray level 5, there are total number of pixel is 850. Now for the output gray level 6, there are total number of pixel is 985. For the output gray level 7, total number of pixel is 448. Now how we have this value? Now just I will explain this. Now just look at here. In the output image, there are no pixel intensity exist. Pixel intensity 0 is exist. And for output gray level 1, there are total how many pixel? For the output gray level 1, there are total 790 pixel. Output gray level 3, there are how many pixel? 1023 pixel. Output gray level 5, how many pixel? 850 pixel. But for output gray level 6, there are total how many pixel? 656 plus 329. That number of pixels exist. Now for this output gray level value 7, there are total how many pixel? There are total 245 plus 122 plus 81. This number of pixels are exist. Now I will just show you here how in the output image the histogram is equalized. Now just look at here, we have just calculate the value, that is nk by n. Now in the equalized output gray level value 0, what is the value of nk by n? That is 0. Equalized output gray level value 1, what is the value of nk by n? That is 0.19. Equalized output gray level 2, nk by n value is 0. Equalized output gray level value 3, nk by n value equal to 0.25. They are almost very close to the value, that is 0.2. So we can say that for this pixel intensity 1, for this pixel intensity 3, for this pixel intensity 5, for this pixel intensity 6, for this pixel intensity 7, there are almost equal number of pixels are exist. And we can see in the final diagram, if we plot the histogram of the output image after histogram equalization, we can observe that the histogram is almost flat. So that is desirable in the histogram equalization. Now again I am coming back to my slide. Just in summary, histogram calculation, next step is CDF computation, next step is CDF normalization, and the next step is intensity mapping, and the last step is equalized the image. And here I will just show you in the original image shown very dark here, but its histogram look like this. Now after histogram equalization, what happened? You can see its contrast is enhanced, visual quality is also improved, and if we see the histogram of the given image, we can see that its histogram is almost flat. So thank you.